Gururaj Korti presents. Pneumatic Lab. Karnataka Law Societies. SHRI VASANTRAO POTDAR Polytechnic Tilakwaddi, Belagavi. Department of Mechanical Engineering. Pneumatic Trainer Kit. Pneumatics can be defined as a branch of fluid power in which gas is used as a fluid. Pneumatic system use air as the gas medium because air is very abundant and can be readily exhausted into the atmosphere after completing its assigned task. In addition, pneumatic systems are less expensive to build and operate. Pneumatic trainer kit consists of FRL unit, manifold, single-acting cylinder, double-acting cylinder, 3 halves push button, 5 halves push button, air motor, control valve. FRL unit. The main 3 elements of FRL unit are air filter, pressure regulator, lubricator. The combined device, which consists of air filter, pressure regulator and lubricator, is known as FRL unit. The main function of FRL are to supply clean, pure and contamination-free compressed air to the system, to condense and remove the water vapor from air, to maintain pressure stability in the air supply, to provide the air with a lubricating film of oil to lubricate the system. Air filter. Air filter. The air filter performs the following functions: to prevent entrance of solid containment to the system, to condense and remove the water vapor from air, to arrest any submicron particles from air. Pressure regulator. Pressure regulator. The main functions of regulator are to regulate the incoming pressure to the system, to measure the amount of airflow at a desired pressure. Lubricator. Lubricator. In pneumatic systems, the compressed air is first filtered and then regulated to the specific pressure and made to pass through a lubricator in order to form a mist of oil and air for the sole purpose of providing lubrication to the mating components of valves, cylinders, etc. Manifold. Manifold. Pneumatic manifolds provide a convenient junction point for the distribution of fluids or gases and are used to provide pneumatic power to 2 or more locations to supply multiple components of pneumatic circuit. Single-acting cylinder. Single-acting cylinder. In single-acting cylinder, the compressed air is fed only in one side. It consists of a cylinder body, 2 end covers, a piston and a piston rod, piston seal, the piston rod and built-in spring. The compressed air is supplied on only one side, left side, of the piston face, and the other side is open to atmosphere. The cylinder can produce work in only one direction. The return movement of the piston is affected by built-in spring or by application of an external forces. The built-in spring is designed in such a way that it will come back to its start position with sufficient high speed under no load condition. The exhaust air on the piston rod is exhausted through the drain hole. For single-acting cylinder with built-in spring, the stroke length is equal to its length of the spring. Single-acting cylinders are available in stroke lengths up to 100 mm. Applications. For pressing operations. For cutting operations. For ejecting ports. For feeding and lifting. For clamping of work, etc. Double-acting cylinder. Double-acting cylinder. A double-acting cylinder, there is no return spring. The compressed air itself is used for movement of the piston in two directions. Here two ports are used alternatively for supply and exhaust ports. They are particularly used when the piston is required to perform work in both directions of motion. Stroke length of cylinder is unlimited but subjected to bulking and bending of the extended piston rod. Applications. Contactless sensing requirements. Rodless cylinders wear is limited. Robotic applications. For increased load carrying capacity. Stopping heavy loads through clamping units and external shock absorbers. Three-way, 3/2, direction control valve. Three-way, 3/2, direction control valve. A three-way, 3/2, direction control valve consists of a three ports P, A and R, that is compressor, pressure, port P, actuator passage port A and exhaust port R. When spool moves to one of the extreme position, the pressured air flows from port P to A. To move the actuator, the exhaust port R remains closed. When spool moves to the other extreme position, the air from port P to A gets closed and air from actuator is allowed to pass through A to exhaust port R. Therefore the valve alternatively connects or disconnects the air supply to the cylinder by the sliding spool. Five-way, 5/2, direction control valve. Five-way, 5/2, direction control valve. Five-way, 5/2, direction control valve are used in high-pressure systems. It consists of 5 ports I.E2 actuators ports, 1 pressure port and 2 exhaust ports. When spool moves in one extreme position, position 1, the pressurized air is allowed to flow from port P to port A, and at the same time port B is connected to exhaust port S. When the spool moves to another extremely position, position 2, the pressure port P is connected to actuator port B and port A is connected to exhaust port R. In each alternative stroke, one exhaust port, either R or S, remain closed. Air motor. Air motor. Air motor is a pneumatic actuator which transfers pneumatic energy into mechanical rotary movement with the possibility of continuous motion. Pneumatic with unlimited angle of rotation are the most commonly used working elements operating on compressed air. Control valve. Control valve, direction control valve. Direction control valves are used mainly to direct the flow of pressure fluid in the desired directions. The main functions of these valves are to start, stop and regulate the direction of airflow and helps in distribution of air in desired line. The moving part in directional control valve will connect and disconnect internal flow passages within the valve body. This action results in a control of airflow direction in a desired path. Created by Gururaj Korti, AMOGH SIDDAPUR, CHINMAY KULKARNI. Follow us on Facebook m.facebook.com, prithviraj.Korti. Instagram Gururaj Korti, Instagram.